One of the intriguing facets of the Earth's geological history lies within the rich and expansive fossils record it has left behind. The journey these remnants undertake through time and ultimately decompose evolves into impending fossils exposed to a mechanism known as fossilization. Fossilization begins when an organism's remains or its imprint is preserved and transformed into rock-like structures by processes such as permineralization, replacement, and recrystallization. This process is dependent on the environment in which the creature existed and the materials its body was composed of. For instance, harder materials like bones, shells, or teeth are more likely to be fossilized than softer tissues. Certain conditions support fossil formation more than others. Quick burial, for instance, can prevent the decay of organic material, allowing a much higher possibility of fossilization. This usually happens in environments like river deltas, lakes, or shallow seas where sediments can quickly cover the remains. Marks and prints left by organisms, known as trace fossils, can also form oxidized residues. For instance, dinosaur footprints are examples of trace fossils. Eventually, the artistry of mineralization replaces organic matter with minerals, paves way for intricate detailing, and culminates into creating the fossil impression that closely mirrors the original structure. An understanding of the history of this captivating process casts light on multiple epochs of our Earth's life, from the Cambrian explosion 540 million years ago, which saw the emergence of most major animal phyla, to the extinction of the dinosaurs some 66 million years ago. The formation of fossils is a rare event. For every billion organisms that have lived, perhaps only a single fossil remains. This makes each fossil a treasured possession, a testament not to just the organism it represents, but to the bygone course of the Earth itself. The fossil record is also an analytical prism through which we can explore the trajectory of evolution on a scale of hundreds and thousands of years. It offers a non-linear visual source, allowing to observe what life was like in the past, to see how it has transformed and evolved in various geological epochs, thereby elucidating the story of life on Earth. Furthermore, fossils are of significant use to gauge the existence or absence of certain species in a particular duration, thus helping to evaluate broad patterns and timescales in the context of evolution. Nonetheless, there are also repercussions that come from improper use of fossils. For example, overexploitation of fossil sites, archaeological theft, and illegal use of fossils by collectors has led to numerous ethical concerns. Furthermore, the extraction process of fossils can cause significant environmental disturbance. This includes altering the landscape and, in some severe scenarios, has even led to the extinction of some species. On the other hand, fossil excavation, examination, and study are intrinsic aspects of paleontology and archaeological study. Fossils found in geographical areas different from their present habitat help establish the idea of continental drift. In other words, fossil evidence has largely contributed towards the modern understanding of Earth's tectonic plate movement. Nonetheless, when these conditions align, the result is an enduring record of life in the form of a fossil. Evidently, from the Cambrian explosion to the extinction of dinosaurs, history revealed through fossils is captivating and thought-provoking. Despite the ethical and environmental implications brought about by its extraction and misuse, the scientific value of fossils is immense. By interpreting the clues locked within these natural time capsules, scientists and researchers are paving the way to unraveling the mysteries that shroud the Earth's biodiversity and its history.